Okay, today we're going to talk about section 6.1, which is angle measure, and we're going to do a quick review of degrees and radians here before we start in with more right triangle trig, which is what is more addressed in section 6.1. Degrees, remember, are units of rotation around the origin. When you're thinking about degrees, you're thinking about actually rotating around the origin. And so 1 degree, if you think about it, would be 1/360th of a revolution, because there are 360 degrees in an entire revolution around the unit circle. Whereas radians are units of rotation along the circumference of the unit circle. So radians are more thought of as, units of distance along the circumference of the unit circle. One other thing I want to point out to you is whenever you're measuring angles, sometimes people refer to the two sides of an angle. Like, for example, if you have an angle theta right here, the side that you start with, or the side that is at 0 degrees, is called the initial side, and then the side of the angle that where you end at is called the terminal side. Just for a little bit more vocabulary there. This would be a positive angle. Then you could also have a negative angle going in this direction, where again this would be your terminal side, whereas this is your initial side. So this would be a negative angle, and then the red would be a positive angle. Okay, then moving on to the next slide, we have conversions, which hopefully that looks familiar from last class. We're going to do just a quick review of that. If you wanted to convert 30 degrees to radians, remember, we take 30 degrees, and to convert degrees to radians, we use our 180 over pi, or pi over 180 ratio. Since we're converting degrees to radians, we need the degrees in the ratio in the denominator, so we're going to use this one. So we say pi radians over 180 degrees. And in doing that, we can now cancel degrees. And so we're left with radians. So we just multiply 30 times pi divided by 180. When you convert 30 degrees to radians, you see that 30 degrees is equivalent to pi over 6 radians. Okay, now here, what if we want to convert 5 pi over 3 radians to degrees? Same thing. We set 5 pi over 3 radians up. Now we want to cancel radians and be left with degrees. So we want radians to be in our denominator. So we multiply that by 180 degrees over pi radians. We see that radians cancels. Pi also cancels. And when we multiply this out, you see you end up with 300 degrees. Okay, so the next thing we're going to talk about is coterminal angles. And coterminal angles are basically just two angles whose sides coincide, which means that they're two angles who land in the same place on the unit circle. They have different measures, but on the unit circle, they look like they're the same angle. For example, let's say we have an angle such as this, 30 degrees. Then we also, what if we take 30 degrees, so, okay, we have our 30 degree angle here. Now, we take that 30 degree angle and we rotate a full 360 degrees and then 30 more degrees. Do you see that 30 degrees plus 360 degrees is going to land us in the exact same place? So it's going to be what, 390 degree angle? So a 30 degree angle and a 390 degree angle are coterminal because their sides coincide. That means that they appear to be the exact same angle on the unit circle. Also, let's think about this. What if we have a 30 degree angle and we subtract 360 degrees? So in this case, let's take our 30 degree angle and let's rotate around the unit circle in the clockwise direction. 360 degrees. And do you see that again will land us in that same location? So if we say 30 degrees minus 360 degrees, that will give us negative 330 degrees. That again is coterminal with 30 degrees. So 30 degrees and 390 degrees and negative 330 degrees are all coterminal. Okay, so this brings us to the next page. Now we're asked to find an angle. Oop. My pen's not working here. Okay, well, we're asked to find an angle between 360 degrees that is coterminal with 361 degrees. Okay, so if we want to find an angle that is coterminal with 361 degrees, what we need to do is figure out, we either need to add 360 degrees or subtract 360 degrees, depending on what would put that coterminal angle between 0 and 360. So do you see if we take 361 and subtract 360, we end up with 1 degree. So do you see that a 1 degree angle, which is even smaller than that, but a 1 degree angle, and a 361 degree angle, which would be a full rotation plus 1 degree, those would both be coterminal. They would land in the same location. Okay, what about negative 100 degrees? If we want that to be between 0 and 360, what we need to do in this case is take negative 100 degrees and add 360 to that. And if we add 360 to negative 100 degrees, you see we get 260 degrees. And do you see that negative 100 degrees would land us somewhere in quadrant 3? This would be negative 100 degrees. And then positive 260 degrees, do you see that would also, if we rotate counterclockwise, we go around, we would land also somewhere around here. This would also be 260 degrees, because again, this is 270, so it would have to be just before that. Okay, what if we wanted to find an angle between 0 and 360 that is coterminal with 1270 degrees? In this case, we are going to go ahead, we're going to obviously have to subtract, so we say 1270 minus 360, which is going to give us 910. Is that between 0 and 360? Still not. So now we have to take 910 and subtract 360. This gives us 550. Again, still not between the 0 and 360. So we have to subtract 360 again. 550 minus 360 gives us 190. And do you see that 190 is between 0 and 360? So 190 would be our angle that is coterminal with 1270. Real quick, what if we want to find an angle that is coterminal with 7 pi over 3? If you want to find an angle coterminal with 7 pi over 3, then you're working in radians here. And instead of subtracting 360, we would want to subtract 2 pi. If you subtract 2 pi here, you'd have to get a common denominator, so 7 pi over 3 minus 6 pi over 3 would give us pi over 3. So 7 pi over 3 and pi over 3 are two coterminal angles. Okay. Next slide, length of a circular arc. This is a formula that you're going to use to find if you ever need to figure out the length of an arc, and that arc in this case would be the arc that the angle subtends. This arc right here. If we want to find the length of that arc, what we need to do, the length of that arc is referred to as S. you need to multiply the radius of the circle, which is obviously this length, by theta, the angle of the circle. One very important note here, this always must be done in radians. If you try to use theta in degrees, it will give you an incorrect answer. So you have to be very, very careful about that. You have to work in radians. Anytime that you're doing any kind of algebra manipulation with angles, you have to use radians. Degrees do not work. Okay, so let's, in this case, find the angle theta in the figure. So we need to figure out what this angle is. We're given a radius of 5. And we're given an arc length of 10. S equals 10. So to find theta, our formula, S equals R theta, we just fill in what we know. So we know S is 10, R is 5, and we're looking for theta. So we divide both sides by 5. We get 2 equals theta. And remember, anytime we're working with angles in formulas like this, everything is always in radians. So our answer would be theta equals 2 radians. Okay, moving on to the next slide is circular motion. This is, oh no, I missed one. Next one is area of a circular sector. And actually we're going to go ahead and pause and stop this video and start a new one.